Okay, so let's conclude this section with some discussion around different ways to do a data engineering pipeline on AWS. So for the analytics layer, we can have Amazon S3, and the data can be read by your EMR cluster that could be running Hadoop, Spark, or Hive, and that gives you access to open source big data tools that may be great when you're doing a migration from on-premise into AWS. If you're using more AWS native tools such as Redshift, you can use Redshift and Redshift Spectrum to do data warehousing and query the data either directly on S3 through Redshift Spectrum or load it first into your Redshift warehouse and perform queries there using SQL. And then you have Athena, which is going to be serverless for more sporadic queries and to query data directly into S3. As we've seen, QuickSight is for visualization, and you can integrate easily with Redshift or Athena to perform some dashboards and create them, and then use the Redshift or Athena as your internal query layer to get your data in the right form. Okay, now in terms of big data ingestion, what can they look like? Say you have IoT devices and they produce data in real time into a Kinesis data stream. Then we can use Kinesis Data Firehose to ingest the data and send it near real time, maybe every 1 minute, to an ingestion bucket such as Amazon S3. And remember, we can use Lambda functions to transform the data before it gets into S3 in case we need to. Then we can have S3 events, for example, to go through an SQSQ as an optional service or directly into Lambda to notify that a new file has been inserted into S3. Maybe our Lambda function can trigger an Amazon Athena job, which is going to directly query the data into our S3 bucket and insert that into a reporting bucket. And then finally, from that reporting bucket, we could create a QuickSight dashboard or use Amazon Redshift to ingest the data and query it. So we have different tools. It's really mix and match. In this case, it really depends on the type of job you're running and the type of architecture you want to have. But as we can see, it's very easy to go from a real-time layer all the way to a reporting layer using the different tools available to you in AWS. Okay, now if we have to compare the warehousing technologies, I think it's pretty clear, but one last time, it doesn't hurt. So EMR is going to be when we need to use big data tools such as Apache Hive or Spark or other things and migrate that to AWS. We have the architectural discussion to use either one long-running cluster and we'll submit many jobs to that cluster, and we can even enable auto-scaling for that cluster to be scaling based on how many jobs we have pending. Or we can choose a more clustered type of architecture when we have one cluster per job and we can size each job and each cluster independently. Then you have different purchasing options to take into account with EMR to do some cost saving. So spot instances, on-demand instances, reserved instances, all of these are possible based on the node you're using. And so it really depends on, are you willing to lose nodes? Are you willing to run a cluster for a year? These kind of questions. And EMR can access data in DynamoDB through Hive or S3 through EMR-FS. You can use Scratch data on EBS disk, and this is HDFS, or use long-term storage in S3 through EMR-FS, as I just said. Athena is going to be for simple queries and aggregations, and the data must live in Amazon S3. It is going to be serverless for simple queries, SQL, and you're going to have out-of-the-box queries for many services, including cost and billing reports, etc., etc. Athena is very well integrated with AWS, so you can audit all the queries being made through CloudTrail. And finally, Redshift is going to be for advanced SQL queries. You must provision servers. You can leverage as well Redshift Spectrum for serverless queries on S3. And Redshift is going to be really a full data warehouse, and you're expected some kind of sustained usage of Redshift to make your return on investment. Okay, so that's all for big data on AWS. I hope you liked it, and I will see you in the next lecture.